Your typical farm. This is what you imagine, isn't it? Acres and acres of plants, corn, cabbage, you name it, but not everyone can grow it. But what if everyone could grow it? No matter the time, the space, the amount of soil? Well, we can. See, look. I know it looks like a computer. Probably why it's called a food computer.
Behind me right now is one of our scales of technology platforms called the food server. Inside of this box, we're creating climate. Then we're monitoring that climate with sensors. Right, those sensors are creating data, like CO2 data, how much is in there, humidity data, temperature data, about 30 data points per plant. When we encapsulate that and we make the plant recipe, what we're really doing is making a correlation between the environment and what we got. And we put that on Wikipedia. And someone else can then pull that file down, load it into their food computer, and within a tolerance, grow a very similar basil. Essentially, you could be growing the same basil in Boston, in Antarctica, and in the Sahara Desert. Inside of the lab, there's kind of a chassis, right? And this is just a point of registration. And then we have subcomponents. It's just like a computer. So like instead of a hard drive, we have a little box. And that box may use aeroponics, which is very simply just mist in a box. There's no standing water, there's no soil. We've been able to create this broccoli in I think it's about 8 weeks on this cycle, where typically it could be up to 160, 190 days.
Give them that, you get this amazing expression. It's like the plant has 2 hearts. And because it has 2 hearts, it grows 4 or 5 times faster.
Is this the future of farming? Will families become farmers once again? Because as Caleb Harper said, no good answer comes out of 2% of the population, and only 2% of the population is responsible for agriculture right now in the United States. That's nuts. We want people to want to farm, right? I think this is a great solution, but let's keep exploring that idea.